Let's talk about the next assignment, 4.3b. This is geometric sums, when we are adding up a geometric sequence. What is a geometric sum? I got 10 minutes, plenty of time to tell you about geometric sums. So a sum, remember, a sum is when we use this symbol sigma, right, of an, when n equals 1, 2, I don't know, some number up here. Sometimes they use I. Let's use I. Case of I when I equals 1 to n. Right? A sum is when you add up all the terms. Add, and you add up a1 plus a2 plus a3 plus dot 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 plus an. Right? You add up all the a's, all the values. You plug in the 1, 2, 3 as you go along the pattern. Plug in the 1, 2, 3 until you get to the last one, and you add up that particular number. So in geometric sums, there are two kinds of geometric sums. There's two kinds, two types of geometric sums. There are finite sums, and there are infinite sums. Infinite. Finite geometric sums and infinite geometric sums. Two kinds. So a finite sum is when you have a limit, right? When there is, you start and stop has a stopping point. A finite sum has a stopping point. So you have, for example, the sum of n is a sum from I equals 1 to n of some geometric sequence. Right? This is going to be a1 times r to the n minus 1. Right? This will be I minus 1, whatever, I minus 1. So when you add up a geometric sequence like this, here's our sum for the geometric sequence. Right? We have our geometric formula here, our geometric equation, geometric equation here. You see the r value is here. You see the starting value is here. This is our geometric equation to the power of, well, I minus 1, same difference. When you add up a finite geometric sequence, we have a formula that will tell us the sum. I mean, if we have the first 10 numbers, you can just lay them all out. Again, brute force, lay them all out in the calculator. This plus this plus this plus this plus this. Keep typing that until you get all the answer, right? You could do it that way. No problem. Or we have this equation. That we can use to figure out the sum directly. And that equation is we take the first term, a1, times 1 minus r to the n over 1 minus r. And this is the sum for a geometric sequence. This is the formula that will give us the sum of a finite geometric sequence. For example, find the sum. I equals 1 to 10 of 3 times, let's call it 2 to the power of I minus 1. So here's my sum. Okay. I want to find this. I want to find this sum here. I want to find this sum, and I know that my numbers go from 1 to 10. I have 10 values in my sum, and so I need to identify some pieces. I need to know what a1 is. I need to know what r is, and I need to know what n is. I need those three pieces in my equation to lay out my formula. So here, this part right here is a1. So now it's going to be 3 times 1 minus r is right here. Right? That's in my formula. The r value is in the thing in the parentheses to the power. So this is my r. 1 minus 2 over to the power of n, right? To the power of n. N is this ending number right here. That's n. So this is 1 minus 2 to the power of 10 over 1 minus 2. So I plugged in my a1, my r, my n. I found the three values here, there, and there, right? My three pieces, n, a1, and r. I plug those pieces into my formula, and I can get my answer. So this is going to be, let's see, 3 times 1 minus 2 to the power of 10. That's a big number. 2 to the power of 10 is 1024. 1024 over, well, 1 minus 2 is negative 1. So let's see, 3 times 1 minus 1024 is negative 1023 over negative 1. Well, that's nice. The negatives cancel out. I have 3 times 1023, which gives me the answer of 3 times 1023, 3069. 3069. There is my answer for the sum of the first 10 numbers of this sequence here. This would be 3 plus 6 plus 12 plus 24 plus dot 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 all the way up to the 10th number. 1, 2, 3, 4, right? Timesing by 2 every time, right? My r value is 2. Times by 2, times by 2, times by 2, times by 2, doubling every time, starting at 3. This tells me my sum of all those numbers is 3069. So that is for finite sequences. We have this equation here. We need a1, r, and n, and you find those in the equation. Find this in the equation. For finite sequences. Sometimes, though, we want to add up a sequence that does not end. Has no end. Has no end. Goes forever. Goes forever. So how can you add up something that doesn't have an end? Isn't it just going to keep getting bigger and bigger forever and ever? Not necessarily. If it goes on forever, there's a certain rule that you have to follow here. It only works if r is less than 1. You can have an infinite sequence if r is less than 1. What that means is that instead of the numbers getting bigger and bigger and bigger and bigger and bigger, because if it does that, you're going to add up infinity. If the numbers get bigger and bigger, you're going to add up infinity. But if r is less than 1, that means that the numbers get smaller and smaller and smaller and smaller and smaller. And if you go to infinity, eventually you're going to start adding nothing. And so you can get an answer of all of these small pieces added up together to get one big answer. But only if the r is less than 1. Really, I should say the absolute value of r is less than 1. If it's between negative 1 and positive 1, like 0.6 or negative 0.2. A decimal between 0 and 1. Has to be between 0 and 1 if this is true. And so the sum for this, the sum of this, is if you have a sum formula from I equals 1 to infinity of a1 times r to the I minus 1. The equation for this one is a1 divided by 1 minus r. That's the sum. A1 divided by 1 minus r. So I know we're out of time. I want to give you one quick example of this, though. Find the sum of I equals 1 to infinity of 2 times a half to the I minus 1. So first of all, you got to check. Check the R. Is it less than 1? And we're good there, right? It's 1/2, it's less than 1, we're okay. Is 1/2 less than 1? Yes, we're okay, that's fine. So we can do the sum. The answer is going to be, here's my A1. So I'm going to take A1, which is 2, divided by 1 minus a half. 2 divided by 1 minus a half, let's see, that's going to be 2 divided by a half. I have a fraction on the bottom, I'm going to flip a do. This is going to be 2 times 2, which is going to equal 4. And that is going to be my answer if I add up all the infinitely small pieces starting from 2 to infinity. So my R is here, do that on the bottom, do your sum up there. So these two more formulas, again, are going to be important. We are going to go over all the things you need to know for the quiz on Monday. We're having a quiz on Monday on this stuff and the arithmetic sequences. We will go over everything on Friday. Till then, you have a homework assignment tonight. It's page 607. Oops, 607. Numbers, I don't remember. 45 to 57 to 67, 71 to 71 odd, I think. Something like that. I'll put it up on Schoology. Check it out. But that is going to be due on Friday. Use those formulas, everybody. I will check you out next time. Thank you very much. Yes, say goodbye in the chat. Once you say goodbye, you're free to go. I will see you on Friday. Have a great day, everybody. Happy Cinco de Mayo.